Brake calipers are fundamental to a vehicle's braking system, acting as the hydraulic clamp that forces brake pads against the rotors to generate friction and decelerate the vehicle. While the core function remains the same, brake calipers differ significantly in their mounting configurations, primarily categorized as bracketed and unbracketed, or radial direct mount. Bracketed brake calipers, as the name suggests, utilize a separate bracket to interface between the caliper body and the vehicle's suspension or steering knuckle. This bracket is typically a robust piece of metal, often made of cast iron or steel, although aluminum alloys are also used in some applications to reduce weight. The bracket is securely bolted to the knuckle or suspension component. The caliper itself is then mounted to this bracket, usually with bolts that allow the caliper to slide or float relative to the bracket and the rotor. This sliding action is essential for accommodating brake pad wear and ensuring even pressure distribution across the rotor surface. The caliper body in a bracketed design often houses the pistons on one side and utilizes sliding pins or bolts on the opposite side to create a clamping force when hydraulic pressure is applied. In a bracketed system, when the brake pedal is pressed, hydraulic pressure forces the pistons within the caliper to extend and press the inner brake pad against the rotor. Simultaneously, the reaction force pulls the caliper body along the sliding pins or bolts, effectively drawing the outer brake pad towards the rotor from the opposite side. This sliding or floating action ensures both brake pads make contact with the rotor, generating balanced braking force. The bracket itself remains stationary, providing a stable mounting point for the caliper and distributing the braking forces to the suspension. Bracketed systems are generally less complex to manufacture, leading to lower production costs. The bracket can be a relatively simple casting or forging, and the caliper itself can be designed with fewer precision-machined surfaces compared to direct mount calipers. Brake pad replacement in bracketed calipers is typically straightforward. Often removing just one or two bolts allows the caliper to pivot or be easily removed from the bracket, granting access to the brake pads without fully disconnecting the hydraulic lines. The bracketed design can accommodate slight variations in manufacturing tolerances between the knuckle, rotor, and caliper, as the sliding mechanism can compensate for minor misalignments. Bracketed calipers are versatile and can be adapted for a wide range of vehicle types, from small passenger cars to light-duty trucks, offering a balance of performance and cost-effectiveness. As for disadvantages, the introduction of a separate bracket inherently reduces the overall stiffness of the caliper mounting system compared to direct mounting. The bracket itself can flex under high braking loads, and the sliding mechanism, while necessary for function, can introduce some play. Steel or cast iron brackets are susceptible to corrosion, especially in harsh environments. Corrosion can weaken the bracket and potentially affect the caliper's sliding action. Due to the inherent flex and play in the bracket and sliding mechanism, bracketed calipers can sometimes offer a less direct and precise brake feel compared to stiffer direct mount systems. Brake pedal modulation might feel slightly less immediate and linear. The bracket can act as a heat sink, potentially retaining heat near the caliper and rotor, which could marginally affect heat dissipation in extreme conditions. The majority of standard passenger vehicles, sedans, SUVs, and minivans utilize bracketed calipers due to their cost-effectiveness, ease of maintenance, and adequate performance for typical driving conditions. Many light-duty trucks and vans also employ bracketed calipers, prioritizing durability and cost-effectiveness over ultimate high-performance braking. Bracketed calipers are frequently found on motorcycles in these segments, where cost and practicality are key considerations. As for maintenance, inspect brackets for signs of corrosion, cracks, or damage, especially in areas exposed to road salt and moisture. Address any corrosion promptly, potentially with cleaning and protective coatings. Ensure sliding pins or bolts are properly lubricated with high-temperature brake grease. This prevents sticking and ensures smooth caliper movement. Check for wear or damage on the pins, bolts themselves. Periodically check and ensure the bracket mounting bolts are tightened to the manufacturer's specified torque. Loose bolts can compromise braking performance and safety. Unbracketed brake calipers, also known as radial or direct mount calipers, are designed to be mounted directly to the vehicle's suspension upright or steering knuckle without the intermediary bracket. This is typically achieved using mounting points that are arranged radially around the brake rotor's axis, hence the term radial mount. The caliper body itself is engineered to be extremely stiff and rigid, often machined from high-strength aluminum alloy. Direct mount calipers are typically fixed calipers, meaning they do not slide relative to their mounting points. Instead, they utilize multiple pistons on opposing sides of the rotor to generate clamping force. The fixed nature and direct mounting contribute significantly to increased stiffness and reduced flex. In an unbracketed system, when hydraulic pressure is applied, pistons on both sides of the caliper extend simultaneously, directly pressing brake pads against the rotor from both directions. Because the caliper is rigidly mounted, there is minimal flex or movement in the system. This direct and rigid clamping action provides a very responsive and powerful braking force. The radial mounting arrangement also helps distribute braking forces evenly around the caliper and mounting points. Direct mounting eliminates the bracket and sliding mechanism, resulting in a significantly stiffer and more rigid caliper mounting system. This reduces flex under high braking loads, leading to more consistent and predictable braking performance. The increased stiffness translates to a more direct and responsive brake pedal feel. Brake modulation becomes finer and more precise, allowing for better control over braking force, especially in performance driving scenarios. Direct mounting can sometimes facilitate better heat transfer away from the caliper and rotor, as there's less insulation from a separate bracket. Some high-performance unbracketed calipers are also designed with cooling features like integrated heat sinks or air ducts. While not always the case, unbracketed calipers, particularly those made from aluminum alloys, can sometimes be lighter than bracketed systems, contributing to reduced unsprung weight, which benefits handling and suspension performance. As for disadvantages, manufacturing unbracketed calipers and their precise mounting points on the knuckle is more complex and expensive. Tight tolerances are required for proper alignment and stiffness. Depending on the design, brake pad replacement in some unbracketed calipers can be slightly more involved than in bracketed systems. It may require removing more bolts or taking extra care to realign the caliper upon reinstallation. However, many modern designs prioritize relatively easy pad changes. Direct mount systems are less forgiving of manufacturing tolerances. Precise machining and assembly are crucial to ensure proper caliper alignment and performance. The rigid mounting can potentially transmit more brake vibration into the suspension and chassis compared to bracketed systems, although this is often mitigated through careful design and vibration damping in other suspension components. Unbracketed brake calipers are typically found in applications demanding high performance and precise braking control. The enhanced stiffness and brake feel make unbracketed calipers ideal for vehicles where braking performance is paramount, such as sports cars, track cars, and supercars. Examples include the Porsche 911, the Nissan GT-R, and many high-end BMW M models. High-performance sport bikes and racing motorcycles almost exclusively use unbracketed radial mount calipers for superior braking power and control at high speeds. Certain high-performance SUVs and trucks, especially those with sporty variants, may utilize unbracketed calipers to enhance braking performance. From Formula One cars to rally cars, unbracketed calipers are the standard in racing due to their performance advantages. Maintaining the correct torque on the mounting bolts is absolutely crucial for unbracketed calipers. Loose bolts can severely compromise stiffness and braking performance, and in extreme cases could lead to caliper failure. Regular torque checks are essential. Inspect the caliper body for any signs of cracks, damage or deformation, especially after hard use or impacts. Aluminum alloy calipers can be more susceptible to damage from impacts than cast iron. Due to the higher performance demands, piston seals in unbracketed calipers may experience more stress. Regularly inspect for leaks or signs of seal degradation. Bracketed and unbracketed brake calipers represent distinct approaches to caliper mounting, each with its own set of trade-offs. Bracketed calipers offer a cost-effective and versatile solution suitable for a broad range of vehicles, prioritizing practicality and ease of maintenance. Unbracketed calipers, on the other hand, excel in applications demanding the highest levels of braking performance and precision, offering superior stiffness, brake feel, and modulation, albeit at a higher manufacturing cost and potentially requiring more meticulous maintenance. The choice between bracketed and unbracketed calipers is fundamentally driven by the vehicle's intended application and performance requirements. For everyday vehicles focused on comfort, cost-effectiveness, and general usability, bracketed calipers are perfectly adequate and widely used. However, for performance-oriented vehicles where braking is a critical aspect of the driving experience and safety at high speeds, unbracketed calipers are the preferred choice, delivering the necessary responsiveness and control to meet the demands of spirited driving and track use. Understanding these distinctions allows automotive professionals and enthusiasts alike to appreciate the engineering nuances behind braking systems and make informed decisions regarding vehicle design, maintenance, and performance upgrades.